Hi there, this is a second video on inequalities. You may want to familiarise yourself with the first one, which just shows you how to put inequalities onto number lines and introduces what they are. If you're more familiar with it and you want to have a look at solving, then off we go. So hopefully you should be familiar with solving equations. If you're not, then I suggest that you might want to first of all make sure that you're happy with solving equations, because it's pretty much the same thing. So we're going to start with an easy one. 3x is less than 18. All you do is treat it like any normal equation. So I'm just going to start inversing my operations. So I'm going to divide by 3 because x is being multiplied by 3. And if I divide by 3, it tells me x is less than 6. And then I can just put that onto a number line like so. This pretty much works the same way. There's one exception which I'll come to in a moment, where it changes inequalities. With this one here, I'm going to add on 7 to both sides in order to undo the minus 7, giving me 2x is less than or equal to 19. Many students will get to that point and think, wait a minute, 2 doesn't go into 19, I think I must have done something wrong. But it's perfectly feasible to have numbers that aren't integers as your solution, or not whole numbers. So let's divide by 2. With x equals, is less than or equal to 9.5. So it's less than or equal to, so it's a solid dot, and it will go off that way. Here's the exception. Right, with this one here, you might go about solving it by taking away 5 from both sides. If your normal course of action would be to add on 3x, just do that, that's still fine. So we've got negative 3x is greater than 9. Now at this point we have to divide by negative 3. And this is the bit you just got to be careful of, because the inequality needs to switch around. And that's if you multiply or divide by a negative. So that's particularly important that you pay attention to that, because if you don't, then you're going to get it wrong. Okay, bearing that in mind, let's continue. So we're going to divide by negative 3, which means we have x, and that will change to less than negative 3. So we've got negative 3, and x has got to be less than that. Now, you may want to check that by going back and putting it in. So if we take a number that is less than negative 3, so negative 4, we substitute it in, we'll have negative 3 times negative 4 is 12, 5 plus 12 is indeed greater than 14, so it does work. Continuing on, so for this one here I'm going to start by adding on 5x to both sides. So end up with 12 is less than 18 plus 6x. I'm then going to subtract 18 from both sides, giving me minus 6 is less than 6x. Don't confuse what we did before with this one. We're going to be dividing by 6. So even though there's a negative involved on the other side, it doesn't matter. We're not going to change the sign on this occasion. It's only when you divide or multiply by a negative. and therefore we've got our answer there. Okay, I've got one more to look at, which is a quadratic. If you're not familiar with solving quadratics, I suggest you have a look at that before you have a look at this particular aspect of this work. Just going to move this one out of the way so I've got a bit more space. Okay, so if you're familiar with solving quadratics, then you should know you can factorize this one, and that will give us x minus 2 and x minus 3 is less than 0. In order to accurately solve this, you really have to do a sketch. So our two solutions would normally be x equals 2 and x equals 3 if we were talking about it as being equal to 0. You'd have 3 and 2 and then our curve there. Now this one's saying where is it greater than 0? Will it be greater than 0 above the x-axis? So for this one, our two solutions are going to be x is less than 2 or x is greater than 3. And that will give us solutions where this graph is greater than 0. So there's a little introduction to solving inequalities. Don't forget, if you multiply or divide by negative, then that's where you've got to switch the sign around the inequality. Thanks for your time.